Hello everyone, my name is Renan Guarese, and I'm here today to present a work I've done in my period abroad at Halmstad University in Sweden during my master's program at UFRGS in Brazil. This work is called A Proposal for Augmented Situated Visualization Towards EMC Testing. So regarding the focus area of this work, situated visualization is basically a mixture between data visualization and augmented reality, where you get to see and perceive relevant information to the environment you are currently located at, particularly in a way that helps the user to identify the 3D position of each piece of data. Here in this image, for instance, you can see a user interacting with an example of that inside a classroom showing data relevant to it. This sort of visualization has proven to help users in different tasks involving decision-making, including gains in accuracy, time taken, and cognitive effort in different tests. In electrical engineering, EMI stands for electromagnetic interference, which is a common problem where different electrical or electronic devices interfere with each other, giving their natural electromagnetic radiation. In this traditional example here, we see a person using a simple electric trimmer. Here, both the radiation emitted from its motor and the one from the electric energy wiring here causes a TV broadcast nearby to be disrupted. In order to understand and deal with this phenomenon, a field study was created, named electromagnetic compatibility, or simply EMC. Researchers in this area commonly use different pieces of equipment to read, test, and analyze the radiation propagated from different devices in order to understand how they may affect the environment where they're supposed to work in and other devices there. The two most common ways to do this are using an EMC scanner, like the image on the right, and an anechoic chamber, like the one on the left. The EMC scanner is a device roughly the size of a 3D printer, which is able to measure the EMI in a high range of frequencies. The radiation analysis is done with a near-field probe attached to an XYZ robot, which reads and later on renders a 3D graphic visualization of the electromagnetic field around the tested object. The scanner is usually meant for precise readings in small components like circuit boards. The chamber, on the other hand, is meant for large-scale devices. The readings are done with a fixed antenna. The tested object is commonly placed atop a slowly spinning circular platform, which rotates for the radiation to be collected from all sides. The chamber is built as a Faraday cage padded with absorbing material, as to avoid wave reflections and external influences. So here at Halmstad University we have ECH, the Halmstad Electronic Center, which is a facility that works with EMC testing, both with EMC scanners and one of these anechoic chambers. Here we have a video presentation of the facilities. Unfortunately, my Swedish is not good enough to explain the subtitles here, but I can assure you it's a very good facility. Here we can see some examples of the data EMC experts currently use to analyze and test devices. They are usually simple 2D graphics indicating the magnitude of the electromagnetic field, and sometimes these are color-coded. On the left, we can see a solid 3D graph, which, besides occluding most of the data by itself, makes it a bit hard to identify where the tested object was. On the right, we can see an attempt to place data overlaying a schematic for the actual circuit board tested. This type of visualization is currently done ad hoc though. What we're proposing to do here is to use situated visualization in favor of EMC testing. This means that we're going to render the EMC data read directly surrounding the actual components and devices being analyzed. In this way, we expect to help EMC analysts to easily identify where and how EMI is happening in their tests. In this first draft, we propose two different approaches. The first we named Desk Scale EMC VIS. This one uses the data read from EMC scanners and places them over and around small electronic parts and devices. For this, we intend on using computer vision frameworks such as the Vuforia engine to identify the component being analyzed and select its dataset to be rendered in augmented reality. In this next approach, called Room Scale EMC VIS, broader data from different devices can be viewed and compared in the same environment, inside the chamber. In this sketch here, the user is visualizing from an allocentric perspective, where a smartphone is used as a visual portal. Much like that, we can use AR head-mounted displays, like the HoloLens, to render the same information in an egocentric perspective, possibly making it easier for the user to understand the location of each piece of data. So in this video here, we'll see a prototype of some of these concepts, including a preliminary interaction method using the user hands and a hand-guided virtual menu. Here the user is wearing a Microsoft HoloLens to see the virtual data, which also scans the real chamber environment into a virtual mesh. The EMC fields here were measured based on the actual antenna that's placed at the top of the table there. So we're currently working on testing the first draft of this prototype with a set of EMC expert users, so we can find and address any problems with the visualization or interaction methods, as well as getting suggested different ways in which this paradigm could be explored. This test will be held inside the anechoic chamber with a set of interference avoidance tasks, where the subjects will analyze 2D EMI data between two different antennas and move them around as to get an optimal placement, minimizing the interference between them. After that, free experimenting time will be provided to the same users with different instances of 3D data, where they can select multiple frequencies of the data read and compare them. These tests will be followed by a gathering of all participants as to initialize a group discussion regarding the approach. So in conclusion, this was a preliminary work to propose whether and how situated visualization can be helpful in EMC tasks. Thank you all for your attention.